Greetings, Earthlings. Today we're going to go over the quadratic equation, who cares? Applications Part 1. Before we go into that, we have some unfinished business. In the previous video on finding the vertex and axis of symmetry and discussing those, I really did a really bad thing because I gave you guys a very roundabout explanation of how to find this, which is the axis of symmetry, x equals negative b over 2a. I mentioned that if you have these two solutions which correspond to the plus and minus, we can add them and divide by 2, which corresponds to finding the average. That is technically correct, and that's another way of thinking about it, but a much more direct way of realizing this is to simply erase the square root part. So you have negative b over 2a. What justifies that? If you think about it this way, negative b over 2a is right over here. If you want to move to the right and get this solution, you do plus something. If you want to move to the left, you do minus that same something. Since you're adding and subtracting the same number, it would make sense that the middle would have plus or minus 0 or nothing. So you just omit this, and that's how you very quickly always remember. If you know your quadratic formula, you will never forget that it's negative b over 2a. You just take this part and you're done. So again, don't think of it like averaging. You can, but it's a lot more direct to just omit this and realize if you're in the center, you go plus a little bit, minus a little bit. That's exactly how you get these two roots from this center or axis of symmetry. All right, so I wanted to add that very important point. That said, we can now move on to who cares about the quadratic equation. We've been talking a lot about it and just developing it from simple, so for example, we had 2x plus 7 equals 8, stuff like that. Basic algebra. Then we went and did a whole ton of things with expanding, factoring, quadratic equation. So at this point, it just looks like harder stuff, but you may be wondering, why are we doing this? Who cares? So I'm going to give you guys many reasons. You may not need a reason, but this may help your understanding. So we're going to start with what I call 0, which is not an official application, but what I want to start with. So for math, it's both a natural question and it helps us with further study. So for example, if we start off doing this kind of algebra and you're sort of a mischievous kid and you like to have fun and play with math, you might naturally ask, well, what if I did this? What if I made that a squared? Could we not solve it? So it's a very natural question to ask. If you've just been playing with x's, y's, z's, whatever, you might want to try to change the power, and that question is just a curiosity. All right. Also, it's going to be super useful for further math study, and it's just a beautiful thing. So that's kind of 0, where it's an obvious progression. So that's not even a specific application that I'm giving you guys. It's just you would naturally come across it if you kept thinking about algebra. All right. So that said, let's go into the first kind of real application. Let's say you're a farmer. So you have a plot of land, and let's say you have 20 feet of fencing. Okay. So that means, let's say from here to here, that has to be 20 feet. So if we call this side x and this side y, or you could call it length and width, whatever, this is also a y, this is a rectangular field. Then we have 2x plus 2y has to be 20. That's our constraint. Now, since you're a farmer, you want to have as much stuff growing on your plot of land. So you might wonder, should you set it up this way? Should you set it up that way? What kind of plot of land should you make? Should you go like that? Should you make it a square? What should you do? So first of all, let's divide this by 2. So our constraint is that they have to sum to 10. So what we really want to do is maximize the area of this rectangle, which is x times y, length times width. And that's your area. And why do we want to maximize this? The larger the area, the more stuff you can grow on your land, right? So for example, you could have the same 20-foot plot, but you can make it really tiny, and that'll be 1 by 20. So this will be really long. I didn't draw it proportionally correctly, but this 20 would be super long. So then you would, this would be a 9, because they have to sum to 10. So that'd be a 9, a 9, a 1, a 1. So the perimeter is 20, but the area is 1 times 9, which is 9 square feet. So you really can't grow a lot of stuff on a super thin rectangle. All right, so that's obviously not a good idea. So let's see, without guessing and checking, how we pick these dimensions to maximize our area. So we want to maximize this, right? So A is equal to xy. The area is x times y, but we have this constraint. So what we're going to do is substitute from here. So let's say we're going to say y is 10 minus x. So bring the x over, and we're going to plug that in over there. So then what are we going to get? The area is x times 10 minus x, which is 10x minus x squared. Now, this is a quadratic equation, so if you just think back to the previous videos, just treat this like a y. So we have y's and x's, and we can plot this. Because the x squared term is negative, it's actually going to be some sort of upside down parabola. And since we care about the area being maximum, that means there's going to be this point, which is the vertex, where this is at the peak, at the highest value. So that's the point we want to find. How do we do that? Well, previous videos finding the vertex, which is why we did that, and that's why it's an application. So I'm just going to cheat and use the formula of x is equal to negative b over 2a to find the axis of symmetry. And then if you plug that into here, so well, let's figure out what it is first. So let's rewrite this. So a is negative x squared, because I want to write it out from quadratic terms to linear to numbers, so it's easier to see. So I'm just going to reverse these. Plus 10x. Okay, and then the constant term is nothing. There's no constant term. So the b is 10, so it's negative 10. The a is negative 1, so but times 2 because it's 2a, so that's negative 2. So that means x is equal to 5. So what that means, if we set this to 5, then this would also have to be 5 for the perimeter to sum to 20. So it would be 5 by 5, and that gives us an area of 25 square feet. So again, how did I find the actual maximum number? I just plugged in this 5 into xy. So, or rather, you can do it any way you want. You could plug the 5 into here to find the area. So that's 50 minus 25, which is also 5 times 5. Or plug this 5 in to x, and remember that x plus y have to be 10, so you could work out that that has to be 5. There's several ways. All right. So again, notice, if we pick 5 and 5, that's a square plot. The area is 25 square feet. If we just say, hey, let's make this 1 and 9, the area is only 9 square feet. So if you're a farmer, this is like a real life problem. If you're a farmer and you're just randomly plotting land, and by the way, why do we need a fence? Well, maybe you have wild animals and you don't want your animals eating your food. So you could set up your fence this way, and then you won't feed your family and you're going to starve. Or you could set it this way and feed a larger family. All right, so that's number one. That's kind of a math example, but if you want to try to stretch and make it a real life example, it has very real applications for farming. In the next few videos, we'll go over some other applications from other disciplines.